The maintenance phase is the final step in the software development lifecycle. So this lesson explains the process and outcomes of the maintenance phase. So this phase, the maintenance, actually occurs after the product is in full operation. So maintenance of software includes software upgrades. So that means implementation of new requirements after the software is deployed at the customer location. Software repairs. So that means handling the residual errors that may exist in the software even after the testing phase, and fixes of the software if it breaks. So it also includes monitoring of the system performance. So software maintenance is actually just not limited to the correction of faults. It also includes accommodation of new or changed user requirements. It includes adapting software to the changed environment. It includes monitoring performance, everything. So it is about evolution rather than just maintenance. So this phase is actually the least glamorous step and also most important step of all, and it goes seemingly forever. Key to maintenance in development. So the first one, it defines that higher quality means less corrective maintenance. Okay, higher quality actually defines here that if your code is well structured, if the quality of your code is good, that means you have given proper commenting, you have maintained consistency, you have maintained complexity, the complexity of your module is less. So in that way it will throw less error. So that means you have to deal with less amounts of errors, you have to deal with less amounts of repairs. So that means less maintenance, less corrective maintenance. So anticipating changes means less requirements. Anticipating changes is like if you can anticipate the operating system change earlier at the requirement engineering phase, so that means you have to do or make less changes at the maintenance phase. So these are anticipating changes. Even if you can understand future user requirements at the early phase, then you have to do less maintenance. So that's anticipating changes. If you can anticipate the changes in the early state requirement engineering phase, then you have to do less amount of maintenance later. And the next one is better tuning to user needs. The same thing, like if you can understand user changes, like when a software is in operation and the user have the better knowledge of the software, they might ask for an enhancement to the software, a new feature to the software. So if you can anticipate this user need at the early stage, like means at the early stage means you requirement engineering phase, so then you don't have to do it later. So that is better tuning to user needs. If you have better understanding to user needs at the early stage, then it will throw you less amount of maintenance. So the next one is less code. Less code actually concerns with the length of the code. So it defines if the length of the code is not durable, then it will be more complex, and then it will have to do more amount of maintenance. So what we actually do, we actually build our system from a reusable source, right? So that's why we just adapt those changes, we just make those changes that we need in that existing system, right? So that in that way the length of the code actually gets so long, and when we go to make changes in our software, so then we have to do more work over there. That implies more maintenance. So that's why if you keep your code concise, then it will throw you less amount of maintenance. So we have already known about the kinds of maintenance activities. Now I will give a little bit more details about each kinds. So the first one, corrective maintenance. Corrective maintenance actually deals with the repair of faults found. So that means correcting errors. Adaptive maintenance. It actually deals with adapting software to changes in the environment, such as new hardware or the next release of an operating system. So these adaptive maintenance actually it's not concerned with systems functionality. So systems functionality will not be changed here. We will not deal with system functionality here. We will only work with adapting to changes like hardware change or software change, but we will not work with any kinds of operational or functional activities here. So the next one is perfective maintenance. Perfective maintenance actually deals with accommodating new or changed user requirements. So that means here comes the functional changes, like we will work with systems functionality here. So that means you will do enhancement, functional enhancement to your system. It also includes activities to increase the system's performance or to enhance the user interface. So here perfective maintenance actually defines if the user give you new requirements. Okay, suppose they want new feature in the software, so that will be a perfective maintenance. You are changing the functional requirements. And also if you want to you increase the usability of your software, usability, better understanding of your graphical user interface, if you want to enhance your user interface, that will be a perfective maintenance. And preventive maintenance. Preventive maintenance concerns activities aimed at increasing the system's maintainability, such as updating documentation or adding comments or improving the modular structure of the system. Those are preventive maintenance. So if you write well structured code, if you do proper technical documentation, those will be preventive maintenance. So this graph is actually showing the distribution of maintenance activities. So what we usually think about real maintenance, when we hear the term real maintenance, we actually think that it's related with correcting errors, right? But see, correcting errors concerns only 20% of the total cost. Actually the main, like half of the maintenance effort concerns changes to accommodate changing user needs. That means if the user gives you new user requirements, or if you do enhancement if you in your software, those are perfective maintenance, and this will cost 50% of the total maintenance cost. This is the real maintenance actually. And the rest of the 25% largely concerns adapting software to changes in the external environment, and the documentation and everything only cost 4%. Another way to look at the distribution of maintenance cost and prevailing types of maintenance task is along the time dimension. So here we have given 4 time dimension: introductory stage, growth stage, maturity, and decline. So during the introductory stage of a new system, most of the effort is actually spent on user support. Users have to be trained to use the system, so they will often contact the help desk for clarification, and then we have to give them support to understand the system, to have better clarification of the system, and then they will have the knowledge to use the system. So in the introductory stage we will train the user to use the system. And then growth stage. So after that users now have better understanding of the system, they will start to explore the system's possibilities. So now maintenance in this stage is actually concerns with correcting faults. So they have better understanding of the system, they explore it more, they will report the problems, and then we have to correct those problems. So in growth stage, maintenance is actually concerned with correcting those reported faults. So then the maturity state. So here your users are now mature, they actually know about everything of your system. So now they have better understanding and better control of the system, what the system can do, what the system cannot do, they already know. So now they will ask for enhancement to the system. So emphasis on those enhancements are done in the maturity stage. And the next one is decline. So here it actually defines technology replacements, such as going to another platform or changing the user interface. So these maintenance tasks are actually related with technology changes. So now we will discuss about some major causes of maintenance problem. So the first one is unstructured code. It actually refers to badly designed or coded. So if the programmers use long procedures to write their program, or they use poor or inconsistent naming, or if they write high module complexities, or if they use deeply nested if statements, so these are actually refers to bad structured code. Okay, that means unstructured code. So if the program is unstructured, then it's very difficult for a programmer to detect and correct a critical defect which is affecting customers' operations. So that's why well structured code is very important, and it will give you less amount of maintenance work. So the next one is insufficient domain knowledge. So the maintenance programmer could have less knowledge of the system or the application domain, and the reason is there is actually less amount of source to understand the domain or problem. So in many cases the source code is the only reliable source to understand the problem better. So a major issue in software maintenance is then to gain a sufficient understanding of a system from its source code. So if the source code is not well structured, if it's more spaghetti like, then it's less easy for the developers to understand the source code and hence understand the problem better. So these insufficient understanding results in changes that may have ripple effects and may incur further maintenance tasks. Maintenance is also hampered if documentation is absent, insufficient, or out of date. Due to deadlines and other time constraint in initial development, documentation might come off badly. And also sometimes programmers update the code to accommodate new changes, but sometimes they don't update the technical documentation. Then maintenance programmers have to deal with all of these. Now we will discuss about two processes that are frequently used in maintenance phase. Those are reverse engineering and re-engineering. Reverse engineering is the process of recovering the design and the requirements specification of a product from an analysis of its code. So we will do design recovery, and we will also discover requirement specification from the analysis of its code. So it builds a program database and it generates information from that database. Reverse engineering is becoming important since several existing software products lack proper documentation and those are highly unstructured, and maybe they were well structured at their initial state, but through a series of maintenance effort their structure has degraded and now they are not well structured. So that's why we need to do reverse engineering in those existing softwares that are not well structured. The purpose of reverse engineering is to facilitate the maintenance work by improving the understandability of a system and to produce the necessary documents for a legacy system. So reverse engineering is actually very important for the rest of the maintenance process, including re-engineering. So before moving to re-engineering, we will talk a little bit about restructuring. Restructuring concerns the transformation of a system from one representation to another at the same level of abstraction. So here the functionality of the system will not change. In reverse engineering, we did not work with functionality. In restructuring, we will not work with functionality, but in re-engineering, the functionality will be changed. So here, from one representation to another. So the first one is from the transformation of spaghetti-like code to a structured code. So this is a form of restructuring. The redesign of a system is another example of restructuring. Suppose in agile methods, restructuring the code to improve its design is known as refactoring, right? So refactoring is actually a white box method. That means it involves inspection and the changes to the code. So it is also possible to change a system or to modernize a system without touching the code. And here comes the wrapping. Suppose wrapping a text-based interface to a graphical interface. So this is actually a black box method. The code of the old system is not inspected. The input and output are simply redirected to the wrapper. So instead of text-based interface, we will use graphical user interface, and it will also increase the usability of the system. But we will not change anything in the code. We will simply redirect input and output to the wrapper. So this is called a black box restructuring. And these wrapping techniques do not change the platform on which the software is running. So if a platform change is involved in the restructuring effort of a legacy system, then this is known as migration. Re-engineering is also called renovation because the real changes are made to the system. So the functionality will be changed here. Re-engineering is actually reorganizing and modifying existing software system to make the system more maintainable. So this process encompasses a combination of sub-processes like reverse engineering, forward engineering, reconstruction. So this process will combine all the phases that we have discussed. So we know that the reverse engineering process will extract elements and important information from an existing system, right? So the re-engineering process will use this extracted information for analysis and redesign, and it tries to identify the components that have to be reused, and it also identifies those parts that need to be redesigned or replaced. So after the final design has been created in the re-engineering process, the forward engineering process takes over in implementing the system and finally testing the new modified system. So in this lesson, we have discussed about the significance of maintenance phase in the software development lifecycle. We also discussed about the maintenance issues over here, and I hope now you guys understand why maintenance is considered as an individual phase in the software development process. Thank you.